Hello everyone and welcome to the 13th and final Winter 2023-24 update from GavsWeatherVids. So here we are, we have reached the end of our journey, or we will have done when we get to the end of this update, and then all that will be left to do will be to release our forecast next week. So we have done 13, once we get to the end of this update, winter updates, 3 seasonal roundups. Don't forget the NAO forecast for the winter 2023-24 that we released way back in the summer. It's all been building up and building up and building up and culminating to our forecast just 1 week away from the GavsWeatherVids Winter 2023-24 forecast. And it's going to be an epic, this 13th and final video. I can tell you that we are going to throw everything at this. And I'm not worried about runtime either. It'll take as long as it takes. So it's possibly one of the most epic and ambitious videos that I've ever, attempted. So we shall see how we get on with it. But hopefully you'll enjoy it. And if you do, please can you like, share, and subscribe. Thank you so much, everybody, for doing that. We've been producing week after week after week unique content here at GavsWeatherVids. You cannot find the content that we are producing on this channel with these winter updates anywhere else online. So if you could, please can you tell your friends and family about GavsWeatherVids. Spread the word about the content that we're producing here. And we thank you so very much, everybody, for doing that. Thank you so to Richard for the amazing winter updates gift. I love it. Thank you so much, Rick. Beautiful. This will be the final time that you see the winter updates gift, because we have got a special gift just for the forecast that you're going to see next week. So thank you so much, Rich. It's been one of your best. Thank you so much, my friend. Thank you so much to Shrine Brewing as well for all of the help on this video. And for our seasonal winter updates, Richard and Shrine have been working so very, very hard. It really is a collaborative effort, team effort, hashtag Team Gav, as I always say. So thank you so much to Shrine, thank you so much to Richard, thank you so much to Terry Scully as well. I shall do the thanks at the end of the video and during next week's forecast. So just to say that first video shows our 6 AM UK weather forecast. We've also got the Nyquist update coming up for you at 7 PM this evening. Just before then at 6 PM, we're going to be live, so we'll be discussing this epic 13th winter update. We will, if that wasn't enough, be bringing you a 10 to 14 day of map live stream, and of course we'll show you plenty of long range as well. So the live is going to be absolutely epic, and I shall see you later on for that. Right, okay, so let's crack on with the 13th winter update. The first thing I'm going to show you, of course, is the swingometer. The King of Swing, Richard Shaw, has sent it through. So as of the end of last week's 12th winter update, so as of 12 winter updates and 2 seasonal roundups and the NAO forecast, this is how the swingometer is currently looking. Is that sleet? We are now on 53% towards a milder scenario. So we are seeing a further swing as of the end of last week's 12th winter update. We saw a further swing of 1% from mild to cold. We are now at 53% mild, and I think that would be 47% cold. So we are not at all far away from 50-50. When you think where we was, like in the middle of these updates after the first 5 or 6, that is a very, very dramatic swing that we have seen from mild to cold there. Very, very dramatic swing that we've seen over the past 4 or 5 updates. And of course, you're going to find out next week exactly where we end up after all of our winter updates, including sort of 13 winter updates, 3 seasonal roundups, and of course the NAO forecast. You'll find at the beginning of next week's winter forecast exactly where we are sitting. But at the moment, we're 53 to 47% in favour of a mild average winter, and a very dramatic and large swing has taken place from mild to cold. Thank you so much. Thank you so much to the amazing Richard Shaw, our King of Swing, for that. Thank you so much, Richard. And Dar's not happy. I don't think Dar's very happy. Never mind. That's what the swingo was showing. So Dar's going to have to put up with it. Thank you so much, our King of Swing. Okay, right. Here we go then. So we're going to start off this up update with the Arctic oscillation and the NAO as well. So this is how the AO observed and forecast is currently looking. The black line shows where we've been with the Arctic oscillation, the red lines at the end where the GFS ensembles are forecasting the Arctic oscillations go. Remember, this is just an index that's reflecting the atmospheric state, does not drive anything in its own terms, just tells us what the atmosphere is doing. When the AO is in its positive phase, got low pressure over the Arctic over the North Pole. When the AO is in a negative phase, got high pressure blocking over the Arctic and over the North Pole. The Arctic oscillation has been in a long-term positive phase, really, since back in the end of August. So you see, mostly this black line has been in positive territory, with a few little exceptions here and there. The current position with the AO is that we are around neutral, but look at the GFS ensembles going for a real crash in the AO, going very, very negative, actually, with the Arctic oscillation as we come to the end of November, and that lasting to the beginning of December as well. Remember, the red lines are the GFS ensembles, and they look very, very negative indeed. So it looks as though we're going to be shifting into a much more negative phase of the AO. That tells us that blocking, northern blocking, is going to be getting involved. It currently started to get involved and will be getting further involved in the weather pattern. Remember, blocking is a route getting cold air out of the Arctic and down into the mid-latitudes. Of course, where the block sits is the critical factor, so you can be on the mild side of the block, but always interesting when you see the Arctic oscillation going back negative. At the same time, the NAO observed and forecast is looking like this. So again, the black line shows where we've been with the NAO, the red lines at the M, the GFS ensembles are forecasting the NAO to go. We've had the NAO in a long-term negative phase, actually. It did go positive for a while when we had the September heat wave in the first half of September. But other than that, the NAO has been generally trending in a negative fashion through most of this autumn. The current position, it did go positive though about a week or so back. The current position is that we're just here, so beginning to go back towards neutral, and the GFS ensembles are forecast that the NAO will also be going strongly negative by the time we get to the end of November, and then staying quite strongly negative right way through the first half of December, if we believe that. So we have got both the NAO and the AO trending in a strongly negative fashion. This undoubtedly is a signal for colder weather, for more in way of blocking, and for colder northerly and easterly winds. Now, negative NAO in December, when you've got an El Nino, is quite interesting. This is from Eric Webb. This tweet, or this X, I suppose this is now, is from Eric Webb. I think Eric is a government meteorologist in the US. Check this out. Can early winter, December in brackets, North Atlantic oscillation, NAO behaviour, give us any clues about mid to late winter, January to March, NAO behaviour during El Nino events? The answer is yes. In fact, this is the critical part, in fact, December and January to March NAO are significantly and positively correlated with each other over the last 50 El Nino events since 1855. This generally means that during El Nino winters, like this year, a more negative, less positive NAO December favours even more negative NAO for January to March. I won't read the rest of it, but I am going to link to this X's tweet in the description. So the question is, we know that the NAO is going to be negative, if that's right anyway, in the first half of December. Will that keep up into the second half? And if it does, what could that mean? Well, the first set of re-analysis we're going to show you is for negative NAOs excuse me, negative NAOs in December and what the winters were like with that. So the first one I want to show about is positive NAO Decembers and El Nino, just to create a contrast. By the way, we realised this week we haven't got November data. So normally on the final update we will try and bring you November CT and England Wales rainfall projections, or England Wales precipitation projections. But unfortunately it's not been possible due to this the uncertainty plenty, but we're still within the model output. We're not sure how much precipitation is going to be it rain or snow in the closing days of the month. And we're unsure where the temperature is going to land as well. So we're leaving November data alone for this final update this year. We haven't been able to produce those projections for you. However, we have got reanalysis. Say the first set of reanalysis we're going to show you is going to be for the NAO when it's negative in December. But I wanted to start off with positive NAO December. So these are the most positive NAO Decembers and the winters with them when we've got an El Nino. So the first one is December 1982. Very, very positive NAO in that December. The winter of 82-83. Remember El Nino winter, but had high pressure out to our west and low pressure up to the north. Generally, a mild winter. It did get a little bit colder, though, towards the latter stages of winter. February got cold. It got very cold into spring, 1983. The next positive NAO December is 1986. Winter of 1986-1987 is actually a cold winter with high pressure up to the north. Low pressure is to east winds coming in from the northeast. So that is a very mild December in 1986, exceptionally mild in December, but does get very cold in January of 1987 with a very memorable big freeze. The next very strongly positive NAO December with El Nino is 1994. The winter of 94-95 is generally mild with low pressure to the north and high pressure down to the south. Winds are coming in from a westerly direction. And then we've also got 2006-2007, again very strongly positive NAO. That one, high pressure to the south, low pressure to the north. Winds coming in from the southwest. That's another very mild winter, 2006-2007. So if you put all of that together, this is how all Decembers combined look. We have El Nino and a positive NAO in the December, and so you can see why the NAO will be positive in those Decembers. Look at the low pressure to the north, look at the high pressure to the south. It doesn't get more positive, really, for the NAO than that. You know, so as the pattern that drives the index, remember. So the reason the NAO would be very positive in those Decembers is due to the low pressure around Iceland and the high pressure from the Azores into western parts of Europe. This is all January's combined, so we go further on. It's all January's combined when we've had a positive NAO December, and basically we keep that positive phase going. We have high pressure to our south and southwest, albeit in a slightly different position. Low pressure to the north, northeast, possibly some slightly cooler air, colder air could get into northern parts of Europe, but for us, I think really most of the time we keep things pretty mild into those Januaries. All February's combined does raise heights a little bit towards Greenland there, so a little bit of a blocking signal, but nevertheless I think that's indicative of El Nino. You know, El Nino does tend to favour a little bit more blocking towards the end of the winter, but overall we keep things pretty westerly even into the Februaries, and all winters combined when we've had a positive NAO December looks like that. So we get high pressure to our south and low pressure to the north. It is a signal for those westerly winds to continue through the remainder of the winter. But we're not going to get a positive NAO December. The most we'll get, because if we're going to be negative through the first half of the month, we might go positive in the second half of the month to offset it. So the most we'll get is like a neutral NAO December. But what if we get a negative NAO December? Well, these are the most negative NAO Decembers with El Nino, and the first one is 1958-1959. And so these have blocking in the North Atlantic going towards Greenland. We get low pressure set up to our east, and we bring the winds down from a cold northerly direction in that winter of 58-59. Our next winter, when we have a negative NAO December, is 1963-1964. This is a very quiet winter with high pressure over the coast. Remember, we're combining the negative NAO December with El Nino as well. So it's not just that it's a negative NAO December on its own. There's been plenty of those, 1981, 1962, etc., etc. But the key factor is that you've got to put that with El Nino as well. Now, this is a rather anti-cyclonic winter. It has some cold snap, but it's a little bit forgotten. We've got 1968, 1969. That is another very negative NAO December with an El Nino event. This is a proper cold winter. Low pressure gets sent to south. High pressure blocks around Greenland. Winds in from the north and from the east. Has quite a cold December and a notably cold Christmas to do. Yeah, there's a white Christmas in many parts of the country in 1968. Goes milder and wetter into January, and then the cold really bites back the very end of January and February. 69 is a very, very cold, snowy month. We've got 1976, 1977, perhaps one of the coldest winters for America. It is a cold winter for us as well. Blocking around Greenland, a trough of low pressure in Western Europe. The thing with this winter is that it's front loaded, which is unusual for El Nino. Now it starts cold through December and it's pretty cold in January as well. So December 76, January 77 are cold. Then it gets mild for February. That's a little bit unusual for an El Nino December. But what happens is that the cold goes from the west of Europe to the east of America. Through the second half of that winter, it becomes brutally cold across eastern parts of America. I'd say it is possibly one of the severest, coldest winters for eastern, northeastern America on record, 76, 77. And then we've got 2009, 2010. Yes, we did have a pretty negative area in December 2009 with the El Nino event of 09-10. And of course, this again is a genuinely proper cold winter with low pressure to the south and jet stream going southwards as well, winds coming in from that easterly direction. So most of these winters, what's interesting, most of these winters do involve at least some sort of level of colder weather. So if we put it all together, this is how all Decembers combined are looking when we have a negative NAO in December with an El Nino, backing up what Eric Webb said, of course. So we've got low pressure to the south, and a strong blocking signal up to the north. What am I doing with that? So we've got high pressure to the south, and we've got high pressure to the north, low pressure south. I'm getting myself mixed up. Winds coming in from an easterly direction. That includes December 1958, 1963, 1968, 1976, and 2009. So the reason that the NAO is negative, also the AO will be negative as well, of course, but the reason the NAO is negative, so we see high pressure around Iceland, low pressure through the Azores. Now, if we go on to all Januaries, look at this. So all Januaries combined following a negative NAO December combined with El Nino placing blocking to the north and low pressure is coming in to the south, winds heading in from an easterly direction, a cold signal for those Januaries, therefore. And then all Februaries combined, following a negative NAO December, combined with El Nino also, keeping the blocking going. Negative NAO is assumed for the winter period, but December to February, winds in from the east. It's a cold signal for those February as well, despite that there's exceptions such as 1977, which was actually a mild February. And then all winters combined, pretty epic when we have a negative NAO December combined with El Nino. And yes, look at this, we do see that signal again for blocking to be around Greenland. Low pressure is to the south and winds are heading in from the east. That is a cold winter signal for those winters after those negative NAO December. So it does appear, if we keep this negative NAO going, it looks like we're going to have the first half of December, it could be game on for a very, very, very interesting winter. We shall see. Thank you, Shadow Shrine, for sorting emojis out. We've got more analogues data to come later on towards the end of, well, actually at the end of this 13th winter update. Right, QBO next, just to confirm the EC phase of QBO continues. So this is from NASA. We've got the stratosphere up here at 10 HPA. We've got the troposphere, 30 to 50 HPA. That's the boundary level of the atmosphere, like we call the troposphere. Weather is taking place just there. This blue-green area is the easterly phase of quasi-biennial oscillation. And you see how that is descending from the stratosphere into the troposphere. So there it is. This is going to be an easterly QBO winter combined with El Nino. That's quite interesting. We'll have much more about that towards the end of this video. Notice up here we've we're possibly seeing the very, very first signs of an ex-westerly QBO appearing. That sandy brown area there is possibly just the first little sign of the next phase Westerly QBO. We won't actually be in the next phase of Westerly QBO until towards the back end of next year, probably, or in the second half of next year anyway. So don't need to worry about that for the winter, but that probably is the next Westerly QBO phase, just beginning to appear up there. Right, okay, solar activity next. This is how this is looking on our side of this day from solarham.net. We've got various sunspot regions all over the place. However, despite that, solar activity is at low levels, and Solarham is reporting that solar activity is expected to remain at low levels for the next 3 days. This is the GavsWeatherVids solar activity tracker sent through by Shrine. Thank you so much to Shrine for sending this through for us. So, begin to tick up a little bit with solar activity in terms of sunspot numbers. Anyway, so the orange line and orange spots depicting each individual day's worth of sunspot numbers. So, we have, of course, we saw the peak of the solar cycle 25 so far back in the summer. Since then, we've been generally trending downwards, and we sort of last 2-3 weeks did see some really quite low levels of solar activity. We're down there with the orange line and orange spots, which was enough to reduce the trend lines with thick blue and thick red lines. We saw those doing a little bit of a bungee jump, actually, from where they were up here back in the summer. Well, the latest, though, over the past week, is that those daily sunspot numbers have shot back up again. So we're now up here, back to where we was, more or less at the start of these winter updates, actually, at the beginning of September. But underneath where we were back in the summer, where we had our first peak, perhaps, of solar cycle 25. It has been enough. The increase over the past week has been enough to start increasing the green line, which is the 30-day average. The blue line hasn't yet started to increase. That's the 60-day average, but moves around much less. This is from Richard. Thank you so much, my good friend Richard Short, for sending this through. This is spotless days and the current spotless stretch in 3D. In 3D, thanks so to Richard sending this through. So, the current spotless stretch is 0 days, given that every day so far this year has had sunspots. We see that for 2023, we are at 0 days, telling us that every day this year has had sunspots. In 2022, we had 1 day, but didn't have any sunspots at all. And in 2021, we had 64 days, followed by, or preceded by 2020, which had 208 days. And our solar minimum year, of course, 2019, that had 281 days without sunspots, which was 77% of the year. Our comparable year to 2023 from solar cycle 24 is 2012, just here. And 2012 also has 0 days without sunspots. Now, you remember that 2012-2013 was a cold winter and had a brutally cold March, actually, in 2013. So you would perhaps assume that as 2012 is like the comparable year to this year, but 2023 is a comparable year to this year. Next year, 2013, will be the comparable year to 2024. And you probably assume that we might get a winter like 2012-13, but unfortunately, it's not quite as simple as that. It doesn't necessarily work out like that, because every year is unique and individual unto itself, and always, the drivers are very important in every individual year. So, if only long-range forecasting was that simple. Okay, I think I'll have a little break there. Why not? Thank you so to Schreier, and thank you so to Richard for the solar data. That's the last time you'll see solar data for this season winter updates. Next time you see that solar data will be, I think, for the New Year's Day roundup. Can you believe we're already talking about the new year? I don't know, do you? They've certainly come round. Anyway, I'm off on a tangent. We'll pause the video there. When we return, we're going to come back with oceans data. Lots and lots of oceans data to look at in this 13th and final winter 2023-24 update. So you go off and stretch your legs, maybe get yourself a cup of tea, perhaps something a little bit stronger, perhaps a drop of the old magic water. I don't know, and I shall see you in about 2 seconds. See you very soon. Okay, we're back and we're ready to resume the epic 13th and final Winter 2023-24 update from GavsWeatherVids. If you've enjoyed the update so far, please you like, share, subscribe, and show everybody for doing that. We've got so much more to show you. I've only really touched on, you know, what we got to show you so far. So maybe hold off on the lights a little bit longer. I don't know. You like when you like, though. But there is a lot more to get through. Thank you so much, everybody. Let's resume there. And thank you, Shona and Richard, of course, for our amazing winter updates gift. Right, we're doing not so data, we've done that. We're doing oceans data next. Okay, so this is how the oceans were looking when we did last week's epic 12th winter update. Our 4 areas of interest. Just here, got the ENSO region, of course. We've got the Northern Pacific there, Northeastern Pacific in particular, or maybe that's a little bit wrong. So the Northeast Pacific, where we're interested, will be through there, really. We've got the Indian Ocean over here, and we've got the Atlantic Ocean over there. So these are our 4 areas of interest. That's how the setup's looking last week. This is related. So in terms of the ENSO region, we see that El Nino is continuing through the equatorial Pacific Ocean as expected. I think we have seen further strengthening through many regions, and again we have seen strengthening through this eastern portion. So we have had the idea playing out, but we're going to get a Modoki central based El Nino, and last week we were sort of thinking that we might be seeing things starting to cool down here over in the eastern portion of the equatorial Pacific Ocean. But actually over the past week, we're seeing a further wave of strengthening through here. So at the moment, I think we have a pretty uniform El Nino. It's about as warm in the central part as it is in the eastern region, and we wait to go into a proper Modoki central based El Nino. But as I say, obviously you can see from those warm and average SST anomalies through here that all regions are displaying the El Nino signature. Going north into the Northern Pacific, again, that's how things were looking last week with these cold average areas of sea surface temperature anomalies through there and through there. This is the latest, so maybe they've weakened slightly, but the negative PDO signature is continuing around here. So as we begin the winter 2023-24, we are going to have a negative PDO combined with El Nino, which is actually a very, very, very unusual combination. More about that in a moment. Over in the Indian Ocean, again, that's how things were looking last week in the Indian Ocean. This is the latest. So the positive IOD phase continues. It continues to be warmer there, continue to be cooler there. I think we have probably peaked though with the positive IOD, so it's holding steady. And as we progress through the winter, I think we'll probably see that returning back closer to neutral because there's a time lag on that. So this is going to be a positive IOD winter, most definitely. In fact, we can confirm this, what I was just saying, with this from Weather Zone. So this shows that we probably peaked the positive phase of the IOD back at the beginning of the autumn up here. Where we currently are is just there. So we have reduced the positivity of the Indian Ocean dipole a little bit over the past few weeks and whatnot from the peak that we had up there. This is for the week ending the 19th of November, by the way, so there will be an update to this. I don't think it'll move, that grey line will move greatly from there. So yes, I think probably we've had a peak of the positive IOD, but this will be a positive IOD winter. We won't get down to here, which is neutral level. We won't get down to that until before the end of winter, and then there will be a time lag on doing that and the effects that would have on the atmosphere. This is from Bureau of Meteorology, so this is showing the forecast models, how they're forecasting it. We've got Bureau of Meteorology's models themselves. That's the Australian Met Office, of course. Got CanSIPS, ECM2F, Meteo France, the UK Met Office, and they've got a mean down here. So you can see that for December, clearly all these models are predicting a positive, the positive IOD to continue in December. In January, that continues as well. Both the Meteo France model does go back towards neutral actually in January, but rest of them are still going for positive IOD. But by February, most of them have gone neutral. So by February, by the end of winter, we should see the positive IOD going back to neutral. Just CanSIPS keeping the IOD positive bend, and then March and April look like that. So most of the models are back to neutral as we get into the spring with the Indian Ocean dipole. But this will be a positive IOD winter. This is the 7-day change in terms of those sea surface temperature lines. So let's just pull this back to here. So it must be an anomaly, of course, and this is how the season temperatures have changed over the past 7 days. So it just backs up the idea that we have seen further warming in this eastern portion of the equatorial Pacific Ocean. That's not what we expected. We're going to have a Madoki central base El Nino, so I'm still very unsure about whether this will be a genuine Madoki central base El Nino or not, to be honest. In the northern Pacific, though, cooling is taking place over, continues to take place over, cold PDO phase continues, especially around here. In the Indian Ocean, just warming up in most regions, so it's still warming here, but it's warming over towards the Indonesian side as well. We're losing the cold and average sea surface temperature anomalies there. And so that means that we are reverting, with peak positive IOD, I think. And then in the Atlantic, so cooling has taken place through here, warming through here, and we continue to warm down in the tropical and subtropical Atlantic. That looks a little bit tripole-esque, I have to say, but if we go back to this, you can see that, because I don't think I did the Atlantic, did I? You can see that it is warm and average through here, it's cooler than average through there, and then, no, what I'm doing, it's warmer than average through here, it's cooler than average through there, and then it's warmer than average up here. Now it does look a little bit tripole, but not a classic tripole, as we've been saying. We have got to see this area turning a little bit colder to get a classic tripole signature, but it's not that far away as it hasn't been throughout, really since I did the NAO forecast, to be honest. When I did the NAO forecast back in the summer, in June, we wasn't that far away from a negative NAO type signature with a tripole from a CISO temperature in May, and it's stayed like that throughout the year. Really. We're close to a tripole, but we're not quite there with it. We'll have more about the Atlantic actually a little bit later on. Back to El Nino. So the SOI is currently looking like this. Remember, the SOI is an index that's measuring the atmospheric state, doesn't drive anything, just tells us what the atmosphere is doing, measuring air pressure between TT and Darwin. So when the SOI is negative, the atmospheric setup will be reflective of El Nino. When the SOI is positive, atmospheric setup will be reflective of La Nina. You can see we are seeing quite strong positivity, quite strong negativity of the SY, down to minus 16, minus 18, for example. We have got some positive days, though, so not continuously negative. We've got the latest, actually, 25th of November, plus 2. We've got 18th of November, plus 3. Generally, of course, the SOI, though, is in a negative phase, as you would expect, given that we are in an El Nino event. So this is how the trends are looking. The red line is the 30-day average. That is solidly negative. Moves around a little bit, of course, because it's 30-day average, but it's solidly negative, around minus 9. And the 90-day average, which moves around much less, that's solidly negative as well. So that's somewhere between minus 11 and minus 10. Telling us that the atmospheric setup is reflective of El Nino in the Southern Pacific Ocean. CFSB2 is still forecasting a Madoki central base El Nino, by the way. So this is where we currently are, just here. In terms of sea surface temperature, it normally is on the side. Dates and periods on the bottom. So it's somewhere close to 2 degrees above average, about 1.6, 1.7 degrees above normal, I think. And in the central base of ENSO region, and CFS is keeping us around that level until January, and then slowly reducing things as we go in towards the spring, back to ENSO neutral, as you'd expect. This is region 1 and 2, or regions 1 and 2, which is the eastern portion, and you can see that's down here all the way if the forecast is correct. So currently around 2 degrees. So as I say, we're pretty uniform at the moment. We're very close in the central region to the eastern region. CFSB Tubo is forecasting that we go cooler and cooler. So by January, we're just here around 1 degree above average. So by January, we should be 1 degree above average in the eastern portion, and in the central portion, we should be close to 2 degrees above average. That would be a weak Modoki central base El Nino if that was to verify. But I'm a little bit dubious about that. I want to just speak a little bit about the Pacific Decadal Oscillation, the PDO. So, of course, we are in a negative PDO, as we see here. The cooler average CISO temperature there, and just here, that is the signature of the cold phase of the PDO. And you see the PDO has been strongly negative, actually, through most of this year. We're up to October 2023 on this chart. And the PDO is in a strongly negative, or has been in a strong negative phase. I don't think it'll be quite as negative as that for November, but nevertheless, it will still be coming out negative. For an El Nino, that is quite unusual. So on this graph, we go all the way back to the 1850s with this, but we're not going to talk about that far back. But we can go back to, like, I don't know, we can go back to the 1990s. So just here, that is when we have the El Nino of 97, 98. And you see we have a very strongly positive PDO with that. This is 2015, 2016. I think, and we get, again, a strongly positive phase of the PDO during that Super Neo. If we go back to the 82-83 event, that will be just here. Again, we see, we have strong positivity of the Pacific Decadal Oscillation there as well. And even when we've got sort of weaker El Ninos, you do tend to still be positive with the PDO. So, for example, 0910, I think, is just here. Let's find 0910. Actually, so there it is, 0910. So in 0910, we did just about go positive with the Pacific Decadal Oscillation during that El Nino winter. Only just managed it. It's probably the closest we can find to where we are right now. But the upshot is to have such a strongly negative PDO with such a almost in terms of CISO temperature anyway, strong El Nino. That is relatively unusual and really quite rare combination. So we talked about this because our ENSO update. That is probably the reason that despite having a pretty strong El Nino, actually the multivariate ENSO index, which tells us how strongly the atmosphere is responding, it's actually been very muted. That's probably because overall the Pacific is actually in rather a La Nina type setup, despite the fact that we have an El Nino. So we've kind of got the Pacific, the wide Pacific Ocean, fighting with itself, fighting with the equatorial Pacific, if you see what I mean. So generally, the wider Pacific is in a La Nina type setup, I think, this year, due to the negative PDO, and you would expect the PDO to be positive with this El Nino. No, that's very interesting. It is an unusual combination. The closest really that we can find is actually 0910 when this happened. But even that winter did have a slight positivity of the PDO when we got into the winter months anyway. So just a reminder of winter of 0910. December, of course, did see a lot of northern blocking. We had low pressure to the south of it, winds coming in from the east in that December. So it got cold, especially the second half was a cold Christmas to New Year. January, of course, very cold in 2010. High pressure blocking to the north, low pressure to the south, winds coming in from an easterly direction. The coldest phase of that winter was, by the way, from middle of December to middle of January. February reduced the blocking a little bit, but was still there, still in evidence around Greenland. Low pressure to the south of it, winds again coming in from that easterly direction. And the overall winter analogue for 0910, it is a cold winter, as we explained earlier on in this update. Low pressure to the south, high pressure blocking around Greenland, winds coming in from an easterly direction. So I think that's the reason that we've had quite a big hurricane season as well. Probably one of the reasons. The other reason that CISO temperature is actually been so warm. But even with that, I think we would have had a relatively muted I think would have had a relatively muted hurricane season if the PDO had been in a positive phase, because we had that in 2009, of course. You know, we had a muted hurricane season in 2009, despite the fact that generally the atmospheric setup wasn't responding all that well to the El Nino. But of course, so I think that's the reason. Again, moving on to Atlantic hurricane season. So these are scores of doors from Wikipedia. Just to explain that again. So I think this might be a little bit hard for people to understand. So we are in an El Nino, but you would normally expect the wider Pacific to go into a positive phase of the PDO, a positive phase of the Pacific Decadal Oscillation when you're in an El Nino. What is happening, what has happened, what is happening still this year is that despite having a moderate to quite strong El Nino event in terms of the sea surface temperature, is the PDO is actually in a cold phase. So we're combining a warm ENSO phase with a cold Pacific Decadal Oscillation. It is unusual, very unusual actually. It's a rare event for that to happen. The closest time that happened in 2009, 2010, in recent years anyway. And so we are in some ways in uncharted territory. We're in uncharted territory with what's happening with ENSO combined with the PDO. So moving on to Atlantic hurricane activity. So these are the scores of doors for the final time this season. This is the 2023 hurricane season page from Wikipedia. So these were scores of doors. This fall we have had 21 tropical depressions, 20 tropical storms, 7 hurricanes, and 3 major Category 3 or above hurricanes. Those numbers are unchanged from last week. This is how ACE is currently looking, accumulated cyclone energy. Remember, ACE is telling us how much each individual storm and how much the season overall, how much energy each storm and the season overall is emitting. ACE is classified as below normal, near normal, above average, hyperactive. ACE Master Shryan been keeping this updated for us. Thank you so much, Shryan, keeping this updated for us. So for 2023. We're unchanged from last week for our ACE number, 145.60 after 20 tropical storms, 7 hurricanes, 3 Category 3 or above hurricanes, and above normal season is confirmed. Not hyperactive, but definitely above normal. And as we've explained in earlier updates, that also is an unusual occurrence when we have an El Nino, such as we have this year. And again, I think the reason, or one of the reasons that's happened, is probably due to the cold phase of the Pacific Decadal Oscillation. Right, back to the Atlantic. So, good bits, isn't it? Good. I hope you're enjoying it, everybody. So, back to the Atlantic. So, we're going to do a comparison for the final time this season. So, please try and ignore all of this. All of that there, please try and ignore it. You don't have to, but please try to. We are looking here. So that is how the Atlantic is currently looking at the moment as of 24th of November. And so let's go back. So this is how the Atlantic was looking this time last year. So we are warmer in all areas than we was at this point last year. That is 2021. Again, there's not much of a comparison. We are significantly warmer in most areas this year. It was pretty warm in 2021, but it's warmer this year. That's 2020. Again, much warmer this year in the Atlantic compared to similar point in 2020. That's 2019. Again, it's a lot warmer this year. And that's 2018. Way warmer this year in most parts of the Atlantic than we was in 2018. That is 2017. What do you think about that one? That could be a slightly closer one, but I think, again, we are significantly warmer this year to 2017. Back 2016, again, warmer this year. 2015, back the cold blob, of course, and again, we can see that we are much warmer this year in the Atlantic than it was in 2015, and 2014, the same is true. 2013, again, much warmer than this point in 2013. 2012, what do you think about that one? Again, much warmer, I think, in most regions. We had got a tripole developing in 2012, though, by the way. Warm, cool there, warm down here. That's a little bit better for a tripole type scene. So let's go for 2011. Again, no comparison this year, 2011. That's 2010. So again, tripole there, cool through there, warm here, warm here. What do you make of that one? You can see compared to that, we aren't that far from a tripole, definitely. But we do really need to see it cooling a little bit more through this region. But I think 2010, I think 2010 might be one of the years that we're closer to, actually, this year. Although it is warmer this year, I think, than 2010. But yeah, that might be one of the closest years. Please let me know in the comments which years you think we're closest to. Whereas there's no comparison to 2009. 2008, again, no real comparison to that year. 2007, I want to make of that one. So again, you know, there's just no comparison really. It's much warmer in the Atlantic now than any of these years. 2006, again, not much of a comparison could be made. 2005, 2004, 2003, all of these years see quite significant areas of cooler average sea surface temperature at 2001, 2000. Now we're moving back closer to the last cold AMO phase, of course, although this is a warm AMO year overall, but we are getting closer to the last time we had a cold phase of the Atlantic, a multi-decadal oscillation. And so all of these years, well, 1998 is pretty warm, but most of these years are going to show significantly cooler Atlantic. Now, that's 1995 for the cold winter of 95-96. Again, no comparison can be made to this year. That's 94. But it's 93. We're now back into the last cold AMO phase. That's how it looks when you're in a cold phase of the Atlantic multi-decadal oscillation. Look how cold it is here, from Greenland all the way down the western side of Europe to North Africa as well. 1992, 1991, 1990, 1989, 1988, 1987, 1986. Look how cold the Atlantic is in 1986 at this point. And lastly, 1985. Goodness gracious me, that is what the cold AMO looks like. And we are a long way from that at the moment. So I think, I mean, there's no year really that we can compare to, but I think the year we're closest to may be 2010, actually, out of all that. But please let me know in the comments which year you think we're closest to. Right, down a little break there. When we return, we're going to look at Eurasian snow cover. So I'll see you in 2 seconds. See you soon. Okay, we're back and we're ready to resume our epic 13th and final winter update. We're talking for 45 minutes, still got a lot to show you, so it's going to be running well over the 1 hour mark. It is easily the most ambitious winter update that I have ever attempted. I hope you're enjoying it, everybody. Please like, share, subscribe if you are. To think that just a couple of years ago, I didn't know if I'd be doing these winter updates again, because I got a cancer in the mouth and you know, I wasn't sure whether this time 2 years ago, whether I'd ever get to do winter updates again. I wasn't sure where things were going with the condition and the treatment I'm going to have. And here we are, embarking in the middle of our most ambitious winter update ever. So thank you so much, everybody, for getting me through, you know, all of the traumas of last year and whatnot. And here we go. Let's resume the 13th winter update. It's epic. Thank you so much from the bottom of my heart, everybody. Right, okay, so Eurasian snow cover next. So this is how things look in terms of Eurasian snow cover when we did last week's 12th winter update. Pretty good. We've got plenty of snow across Scandinavia, and we have got snow line to the northwest of Russia as well. Have a look at the latest. There we go. As of the 24th of November, we have completely covered Russia with snow, really, and we've pushed that snow cover into eastern parts of Europe as well. Scandinavia still doing pretty well for snow cover too. Now, most parts of the Nordic regions are covered, just southern parts of Sweden are uncovered. But a big gain in snow cover across western parts of Russia. Right, let's start comparing then. So how do we compare with the same point last year? Oh, this is the week change, sorry. I thought I'd just throw this in, week animation. I haven't shown that before. I forgot to put that in. So that's how we've gained over the past week. I might start showing that from next year's update, so you can see what's happened over the week. A little bit of fun there, a little bit of fun with that. Right, let's start doing the comparison then. So this is how we compare with this point last year. So, I mean, we're probably a little bit lagging, actually, at this point in 2022. Despite the big game we've had over the past week across Russia, we're probably a little bit down on 2022 for Russia and also the Nordic regions. That is 2021. We're up on 2021. We're ahead of 2021 for Eastern European snow cover and Russian snow cover and also Nordic snow cover. That's 2020. So we're ahead of 2020 as well. Most areas, that's 2019. We're ahead of 2019 in the Nordic regions and also across Russia too. That is 2018. So, again, I think we're ahead of 2018. That's 2017. I think we're ahead of 2017. So, for Russian snow cover, probably for Nordic snow cover too. That is 2016. What do you make of that one? So, again, I think for 2016, we are ahead of that year, certainly for Russian snow cover. Okay, that's 2017. So, again, we see that for 2017. We are probably a little bit ahead of 2017 as well. That is 2016, sorry. So, for 2016, we are very close there for Nordic snow cover, maybe a little bit ahead. And we are ahead of 2016 as well for Russian snow cover. That's 2015. So, for that year, we are probably a little bit ahead for Russian snow cover. And probably a little bit behind for Scandinavian snow cover. That is 2014, no comparison. Look how lagging it was at this point in 2014 for snow cover there. That's 2013, again. We are well ahead of 2013, certainly for Russian snow cover. That's 2012, ahead of that year for Russian and also Scandinavian / Nordic snow cover. 2011, ahead of that year as well. We're doing really good, aren't we, now for snow covers come to the end of the autumn. That is 2010. So we're ahead of 2010 for Russian and Eastern European snow cover, but probably behind for Scandinavian Nordic snow cover, actually. 2009, we're ahead of that year as well in all areas. 2008, wow, that's very interesting. Yeah, we've already got snow into France at this point in 2008. Most of Germany was snow covered. So that year, yes, I think we are well behind, actually, that year. 2007, so probably quite close to that year, actually, maybe a little bit behind, though. 2006, what do we make of that one? So I think we are probably ahead of 2006, certainly for Russian snow cover, probably for Nordic snow cover too. 2005 is interesting, lagging across Western Russia, quite a bit through central eastern parts of Europe, though, and lagging over the Nordic region. So that's a very different one in 2005. 2004, I think we're a bit behind 2004 for snow cover in most areas. 2003, probably a bit ahead of 2003 in most regions. 2002, I think we're ahead of 2002, certainly for Russian snow cover. 2001. For that one, we are probably quite close, maybe a little bit ahead. 2000, again, probably a bit ahead of that one as well. 1999, I should say, we're behind 1999, though, particularly for European snow cover. Most parts of Europe were covered at the end of November 1999. And 1998, again, we're behind that year as well. Just go a little bit further back. So we won't do a comparison now, but just keep that in mind. It's a current situation. Sort of flip that on its head or turn your head upside down. So for 1997... I think we're behind 1997 at this point for snow cover in most areas. 1996, again, we are ahead of that year for Russian snow cover, probably for Scandinavian Nordic snow cover too. 1995, I think we are probably quite close to that for Russian and Eastern European snow cover and for Scandinavian Nordic snow cover as well. Again, please let me know in the comments which years you think we're close to. It's all subjective in my opinion, so I'm sure you'll all have different opinions. Let me know, everybody, in the comments. 1994, probably quite close to this year. 1993, we're well behind 93. 92, again, probably quite close to this year. 1991, close this year for Russian and East European snow cover, but behind for Scandinavian Nordic snow cover. 1990, ahead of that year in all areas, I think. 1989, we're behind that year in most areas. 1988, we are behind that for Russian, East European snow cover, but ahead for Scandinavian and Nordic snow cover. 1987 could be quite close to this year. 1986, we're ahead of that year for Russian and particularly for Scandinavian Nordic snow cover. 1986, We are well behind 1985, I should say, well behind that year. That's 86, which we're ahead of. But 1985, we are well behind that year. 1984, we're ahead of that year in all areas. 1983, we're behind that year for Russian European snow cover, but ahead of Scandinavian Nordic snow cover. 1982, I think we're ahead of that year, especially for Nordic snow cover. 1981. Probably quite close to this year, I think, with that one. Perhaps a little bit ahead this year, though, for Eastern European. 1980, I think we are ahead of that year in all areas. We're ahead of 1979 as well. 1978 could be a closer one to this year as well. Some interesting years that we're quite close to this at the moment. 1977 looks like that, probably ahead of that year. And 1976, I think we're ahead of that year as well. 1975, we're ahead of that just about. To 1974, could be quite close, probably a little bit behind Scandinavian Nordic snow cover. We're behind 1973. 1972, that could be a closer year for Eastern European and Russian snow cover. 1971, probably quite close to this year. 1970 could be quite close. We're a little bit behind 1969. This year, I think, 1968, again, might be quite close to that year, perhaps a little bit behind it. 1967, we're a little bit ahead of that year, I think, particularly for Scandinavian and Nordic snow cover. And finally, 1966, again, we can see that could be quite close for Russian and Eastern European snow cover, but we are ahead of that year for Scandinavian snow cover. That's the last time we'll be doing that this season. Okay, we're going to pause the video for the final time. When we return, we've got stratospheric data to show you and our final set of analogues as well. So when we return, we'll be going right way through to the end. I'll see you in 2 seconds. Okay, we're back and we're ready to resume the 13th and final Winter 2023-24 update from GavsWeatherVids. This is the final section of this final video, so once this part of the video is out of the way, we're done. And that'll be it for our winter updates. It's been a true epic, probably the most ambitious winter update I've ever attempted. I hope you've enjoyed it. If you have, please like, share and subscribe. And we thank you so much, everybody, for doing that. Right, let's do this then. We've got to show you stratospheric data for this last section. Always important what's going on in the stratosphere. So, Shrine did this for us. So, this is Sudden Stratospheric Warming Explanation. Always a lot of interest in SSWs. I think some people do get a little bit confused about sudden stratospheric warmings. So, this is all you need to know. Sudden stratospheric warming, or SSW for short, refers to all warming events of the stratosphere. There are 4 different types of SSW. 1. Major, a reversal of zonal winds in the upper stratosphere, 10 HPA over North Pole, 60 degrees north. Minor, a significant warming without a reversal. Canadian warming, a modest warming over Canada via blocking high pressure that typically occurs in November or December. You will not get a reversal with that. 1962, November 1962, I believe, had that. And then the final warming, I should say. So that is the final warming of the boreal winter season before summer. Zonal winds reverse easterly until late August. This warming happens in March or more frequently April or May. During a minor SSW, the stratospheric polar vortex gets displaced from the North Pole, whilst during a major SSW, the stratospheric polar vortex can either get displaced or split into 2 vortices. Thank you so much to Shrine for explaining, for our explainer, what an SSW is. Right, okay, so let's have a look at temperature at 10 HPA over the Arctic of North Pole versus average. The black line shows where we currently are. The temperature at 10 HPA, the grey line is the trend line. You can see we are around just a little bit colder than average with the temperature at 10 HPA, somewhere in the mid-70s. Not a particularly big deviation. Go a little bit lower down to 30 HPA, this is from a JMA, of course. Go a little bit down to 30 HPA. You can see that at that level, we are actually further under the grey line. So it is a little bit colder at 30 HPA than it is at 10 HPA. Both regions, both levels of the stratosphere are a bit colder than average, but not doing anything overly dramatic. Let's look at the forecast then from the GFS for the next couple of weeks. So the blue-purple area, this is the polar vortex at its roots in the stratosphere over the North Pole. So the GFS is predicting that the temperature will become very cold actually on our side of the stratosphere, going down to around minus 84. But over the pole itself, we did hover around the mid-minus 70s. So if these purple colours were further north, we would see the temperature here, the black line here, doing a proper plunge. It will be going down to around there. But that's not going to happen, I don't think, because those purple curves are over towards the Greenland side of the Arctic. Over the Arctic itself, over the North Pole itself, temperatures will hover around the mid-minus 70s. Right, we get through to the beginning of December. A minor warming of the stratosphere is occurring over Siberia. Not an SSW, but a minor warming is taking place over there. As we run through into the second week of December, we can see that overall the polar vortex continues, but notice it is beginning to get a little bit displaced and stretched via this warming here. So that is quite a significant warming that's happening over Siberia. It's short of an SSW, of course, but quite a significant warming is happening there. And it is moving towards Canada as well. It is not to start displacing and stretching a PV at its roots. So that's how we end up on the 11th of December. Quite a stretched, a rather displaced polar vortex taking place at that point. But it's still very early in the winter to be seeing any signs of warming, really. So that is of note. This is the extended temperature at 10 HPA forecast from the ECMWF. So this is the warming that I'm just talking about over Siberia at 10 HPA in the next week or two. We go through the week 2, which is the 4th to the 11th of December. That intensifies. You can be sure of an SSW, but as we see here, you know, that does lift the temperature up and displaces the PV at its roots over towards northern parts of Europe. Week 3. Looks like that again, above average with the temperature anomaly, but short of an SSW. Week 4 begins to shrink that area of warmth a little bit. Week 5 looks like that. That's Christmas week, 25th December versus January. Again, the warm area is shrinking a little bit. And then week 6 looks like that. It's the 1st to the 8th of January. So still above average with the temperature anomaly at 10 HPA even then. But, you know, reducing it. And up to the new year, it doesn't look like we're going to get a technical SSW, but this should be enough to weaken the zone of wind. So another way of depicting the polar vortex is in the strength of the zone of wind. So you can see that at the moment the zone of wind is actually very strong up here, despite temperature not being all that cold. It is a bit cold average at 10 HPA, but the zone of wind is actually very strong at 10 HPA. Job to make out a thick blue line, but you see that does reduce under here, which is like average, I think. So you see that the zone of wind is weakening as we're going through the first half of December down here. This zero line quite important. Any ensemble member underneath that is going for a reversal of zone of winds. These ones down here are doing that. So we are going to reduce the strength of the polar vortex as we get this warming and slight displacement and stretching of the PV at its roots. We are going to weaken the polar vortex. Doesn't look like we're going to send the polar vortex into reverse before the new year, but all quite interesting that for this early in the winter we're already seeing signs of quite a significant weakening of the PV. So we're looking, I'll just show you what an SSW looks like if anybody doesn't know. And that's what we're looking for, you know, to send the zone of winds into reverse, to split the polar vortex, etc. So I'm going to show you what happened in the winter of 1946, 1947. Now, I don't know how they've done this at Metroseal, because as far as I know, we didn't start measuring stratospheric temperatures until, like, the 1950s and 1960s. So I don't know quite how they've come up with this, but this is something that I don't think anybody has ever seen before. I only noticed the other day that these charts at Metroseal were going all the way. They used to go back to the end of the 1950s. We're now going back to the end of the 1940s. So, and I don't think that's been the case, you know, for very long. So I don't think many people will have seen this. So this is how we look in terms of the temperature at 10 HPA over the North Pole on the 3rd of December 1946 for the daddy of snowy winters. Again, you see the blue colours there, that is the polar vortex at its roots in the stratosphere. Now we go over to the 15th of December 1946. Again, you see nice PV depicted there. Let's go to Christmas Day 1946. Again, polar vortex having a little bit stretched there, but it's still well and truly in business. There is a minor warming that's happening over Siberia. Let's go through to New Year's Eve 1946. That minor warming from Siberia has moved into northern parts of America. Still, though, the polar vortex itself is well and truly in business. Now let's go into January of 1947 and see what happens then. This is unique content, everybody. I bet I wasn't expecting to see stratospheric reanalysis from the winter of 46-47 at the start of this video. I thought I'd throw it in, you know, just for fun, as it is the last winter update. This is January 1947. Again, which is New Year's Day, I should say, 1947. Again, blue colours, that's polar vortex, have got warming over North America. This is when it starts getting interest. Let's go over to the 5th of January. So then we're seeing warming on either side of the pole beginning to appear. Well, another warming beginning to happen over Siberia. At the same time, a bit of a warming is happening in the Atlantic as well. Let's go through to the 7th and see what's happening then. So the warming in the Atlantic and into Europe is beginning to gather pace. We've still got the warming over Siberian side, relatively modest, but it is stretching and stretching the polar vortex actually. Those blue colours, it's stretching that to its limits. Let's go through to the 8th of January, and the warming is intensifying to the south of Greenland there. SSW beginning to take place. 9th of January 1947. We are splitting the PB. Notice the two lobes of blue that Schreiner talking about begin to split into two as the warming is happening on either side. 10th of January 1947. Looks like that we have split the PV, and we are, you know, seeing a significant southern stratospheric warming event occurring. So the winds at this point would be in reverse, I would assume. That is the 11th of January 1947. Major warming of the stratosphere is taking place now. Southern stratospheric warming is occurring. And look at that, 12th of January 1947. The SSW is confirmed. It will be around 10 days after that the winter will kick off, and the rest of the winter of 1946-1947 was brutally cold. The daddy of snowy winters, definitely severe cold. February, very, very snowed up indeed. And it was all preceded by a very, very significant, a major southern stratospheric warming that split the polar vortex, reversed the zone of winds. Look how epic that looks on the 14th of January 1947. That's the kind of thing that we're looking for if we're going to get an SSW this winter. Absolutely beautiful and classic example of a southern stratospheric warming for the daddy of snowy winters. So what are the chances of an SSW this winter? Well, let's go back to the presentation that Richard gave us on the very first winter update. So you'll remember that back on the first winter update, Richard brought us this presentation, and he was looking at various things, but particularly looking at solar activity, QBO, and ENSO, but particularly combining the QBO with ENSO. I won't go through the whole presentation, but if you want to see that, please check out the first winter update. It's absolutely amazing. It was an absolutely amazing presentation from Richard. Thank you so much, Richard, for the presentation that he delivered us, set us up and set us off on the first winter update. I always wanted to and intended to return to this in the final update. So for SSWs, Richard noted this gets interest with regards to southern stratospheric ones. When ENSO is moderate, the chance increases to around 77%. Recently, in the last 17 moderate El Niños, 13 have had SSWs in the winter. Enhanced snow cover over Siberia has a 64% chance, so not strong. ECQBO phase gives us a 90% chance of SSW in the last 20 winters. So based on everything above, a chance of a sudden stratospheric warming is around 77 to 80% chance of happening in winter 2023-24. So for our last set of analogues, we're returning to what Richard was discussing in his presentation. So this, everybody, is the final set of analogues that you are going to see for our winter updates. The first ones I want to show you, though, what we're going to look at is El Nino combined with the EC phase of the quasi Alsatian that has sudden stratospheric ones. But the first thing I want to show you is when we have El Nino with a westerly phase of the QBO. And we get an SSW. So you see the difference in the response. So these are the winters that have a westerly QBO with an El Nino and a sudden stratospheric warming. It's 1969-1970, 1972-1973, 1987-1988, 2006-2007, and 2018-2019. This is how all Decembers combined are looking with that. So we get high pressure set to our east, low pressure out to the west. It's an anticyclonic signal for the Decembers and probably relatively mild given the position of the ridge. We might pull in some colder air from east, but generally quite mild. All Januaries combined, which is January 1970, January 1973, January 1988, January 2007, and January 2019, where we have an SSW with an El Nino and a Western QBO. It's a mild signal. Low pressure is in from off the Atlantic. A little bit of blocking around Greenland, possibly from the SSW, but really quite muted. That is all February's combined. Slightly better for a colder outcome when we're in a Western QBO with an SSW and an El Nino. So a little bit more blocking, more towards the Canadian side of Greenland though. Trough low pressure over the northwest Europe. We could get some colder weather in those Februaries, but again, it's not brilliant, to be honest. This from a cold perspective, and this is how all winters combined are looking when we have an SSW with an El Nino and a westerly phase of the QBO. Yes, there's a little bit of blocking, probably as a response to the SSW, but overall low pressure is still the driving and dominating factor. Now, what about those winters that are El Nino winters with an easterly QBO? And they have an SSW as well. So the first one, again, it's 1958, 1959 with high pressure out to our north and winds coming in from a north or a northeasterly direction. That turns cold in January. We've got 1965, 1966, high pressure is blocking to the north, low pressure is to the south. That has a very cold December and also into early January as well. Gets milder for February though, quite a strong blocking signal. What about the next one? It's 68, 69. Yes, the winter of 1968, 1969 had an easterly QBO. It was an El Nino winter, and it had a sudden stratospheric warming. It is a genuinely cold winter, as I explained earlier on, blocking around Greenland. Low pressure is to the south, winds in from the east. It gets very cold in February of 1969. We've got 1976, 1977 showing up again with blocking to the north, low pressure to the south. That also combines the SSW with the El Nino and the EC phase of the QBO. We've got 1970, 1979, 1980. That was not quite as interesting with low pressure to the south, high pressure is to the north. It does have some cold snaps though. And then we've got 1986, 1987. That also combined the EC phase of the QBO along with an SSW as well. So blocking in the north, winds coming in from the east and from the northeast. Got 2002, 2003. Again, with high pressure to the north, winds coming in from the east. You look at it's cold winter, it's not overly. And then we've got 2009, 2010. That one also with high pressure up to the north, blocking around Greenland, low pressure to south, winds in from an easterly direction in 09, 010. So this is how all Decembers combined are looking when we have an SSW combined with an El Nino and the EC phase of quasi-Siberian oscillation with low pressure to the south, high pressure is to the north, so maybe a little bit of cold potential even in the December. But look what happens when we get into the Januaries. Clearly the blocking signal strengthens a lot around Greenland. Low pressure gets sent to south, winds in from the east, and then we go through into So I tell you what, I thought that was wrong. Let's very quickly go back to that. So here we go. Why have I put that there? That shouldn't be appearing there. 86, 87 should be appearing there. So sorry about that, everybody. That's not in the list of all years combined, is it? Yes, it is, 86. Oh, right, okay, well, there we go. Right, okay, I'm not sure if that should have been there. I don't think 86, 87 should have been there. I think that was a westerly QBO phase. Anyway, never mind. So this is how all January's combined are looking. If 1 year's right, it doesn't really make much difference to the all years combined. You know, 1 year will override, the rest of the years will override the 1 year, you see what I mean? So blocking around green, low pressure, so south winds in from the east in the all January's combined. All February's combined, where we have an SSW, an El Niño, an easterly phase of quasi-biennial station. Again, we're blocking to the north, low pressure is to the south winds in from the east, cold signal for those February's as well. And all winters combined, when we have an SSW with an easterly phase of the QPO, and also when we have a El Niño 2 blocking around Greenland, low pressure to the south, winds in from the east. It's a cold signal for those winters. When we combine an El Niño with an easterly QPO and an SSW, it does increase your chance of a cold winter with blocking. Woo! There you go, everybody. That is the 13th and final 2023-24 update. I'm about done for after that. 1 hour, 15 minutes. I don't know if that's the longest winter update, but I've ever done. Possibly is. And I hope you enjoyed it, everyone. I know there have been a few little mistakes along the way. When you've got such an epic video, you know, these things can happen. But I think we've proven the point throughout this update that we are possibly, and this has been apparent in the last 4 or 5 updates, we are possibly seeing a swing towards a colder outcome. But you'll find out next week with the swingometer how much this final update has moved the swingometer from mild to cold, if indeed it has. I won't prejudge anything. You'll see at the beginning of next week's winter forecast how it's shaping up. And of course, next week is forecast week. So in a couple of days, I will let everybody know times, you know, when the forecast is going to be released, etc. It will, though, be next Sunday, a week today, Sunday the 3rd of December. So watch out, everybody, for when I make the announcement, what time the premiere will be. You will find out next week what we are forecasting, what we are predicting for the winter of 2023-24. It's going to be a very, 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 very interesting forecast after all of this data that we've got to digest. Thank you so much to Richard, and thank you so much to Shryan for all of the help on not just this winter update, but all of winter updates. Thank you so much to Terry as well. Hashtag Team Gav has done an amazing job throughout this season of winter updates. Thank you so much, everybody. And we'll end it there. So I hope you've enjoyed this epic 13th and final winter update. If you have, can you please like the video and share it? You know, tell your friends and family about GavsWeatherVids. We thank you so much, everybody, for doing that. And at 1 hour 16 minutes, goodness gracious of me, how have I done this? I don't know. 1 hour 16 minutes. That's all for now. Thanks for watching. See you next week for our winter forecast. And bye for now.